So let us start from the last class. So in the last class, we have completed, we have started with the standard heat of neutralization. Okay, so let us try to understand what is the exact meaning of what happens in standard heat of neutralization. So what is the meaning of neutralization? Generally, neutralization is nothing but acid reacts with base to give water, salt and water, right? So when 1 gram equivalent of strong acid reacts with 1 gram equivalent of strong base, then the heat released, we should call it as what? Standard heat of neutralization, and its value was found to be how much? Minus 13.7 kilocalories and minus 57.1 kilojoules. Okay, now you will say, ma'am, how to identify which one is the strong acid and which one is the strong base? Okay, there's total 6 strong acid. Those are nothing but HCl, HBr, HI, which is nothing but hydrogen iodide. Next, nitric acid, HNO3, sulfuric acid, H2SO4, and the last one is perchloric acid, which is nothing but HClO4. Okay, strong bases. How to identify strong bases? There are total 5 strong bases. Those are nothing but sodium hydroxide, sodium, potassium, next rubidium, next cesium, and the last one is barium hydroxide. Okay, these are nothing but our strong bases. Apart from that, remaining whatever the example you will get, you can consider it as what? Weak acids and weak bases. Okay, so let us try to understand one small example. What is the theory says that is standard of neutralization. So, okay, for example, if I taking one strong acid and strong base, which is nothing but what? When I react HCl plus NaOH. Okay, so what you are going to get? Obviously, you are going to get a salt. What is that salt? NaCl plus water. Okay, now what happened? Can I say this is a neutralization reaction? Right, the given is what? Neutralization reaction. Now what happened when I say 1 gram equivalent of acid when it reacts with 1 gram equivalent of base? Okay, so you will get the salt and water. Okay, so whatever the delta H heat of combustion, okay, sorry, heat of neutralization. So what is the heat of neutralization value here? Heat of neutralization value is nothing but, suppose if I'm writing kilojoules, so what we are going to get? Minus 57.1 kilojoules. Okay, so actually here what does the minus indicates? Minus doesn't mean that its energy is negative. It indicates what? This amount of energy is released. Okay, so how much energy is released when 1 gram equivalent of strong acid and strong base react? You will, how much energy is released? You should never say minus 57.1 is released. You have to answer 57.1 is released. Why? Because minus, here minus sign indicates that the given value is released. The given value is obtained because of release. Okay, next what happened? I will take when 2 gram equivalents of strong acid reacts with 2 gram equivalents of strong base. So what energy, how much delta H of neutralization you are going to get, which is nothing but 2 into minus 57.1. Okay, I hope you people are understanding what I'm trying to say, right? But this time what I'm going to do, I'm going to take 2 gram equivalent, and here I'm going to take 3 gram equivalent. Okay, now out of that, what should be our answer? Okay, always remember, whenever you get some uneven number, okay, whenever you get different number, go with the lesser one. Go with the what? Lesser one, because lesser one is acting as what? Limiting reagent. Okay, so what happened? What will be our answer? 2 into minus 57.1 here. Okay, now suppose if I take here 2 gram equivalent reacts with 1 gram equivalent. So how much delta H of neutralization you people are going to get here? Which one is a lesser value? 1 gram equivalent. So, okay, here this one is a lesser value. So what we are going to get? 1 into minus 57.1 units are what? Kilojoules. Clear till here? I hope you people understood. And whatever this, all these values, okay, these values, when you can use only if the combination is what? Strong acid plus strong base. Okay, now the question is, ma'am, what happened if I take weak acid and strong base, weak base, weak acid? So let us try to understand for other combinations. Okay, so let us try to understand here. Suppose if I take strong acid plus strong base, okay, what value you are going to get? Minus 57.1 kilojoules. Okay, now the question is, what happen if I take weak acid plus strong base, right? What happen if I take weak acid plus weak base? Okay, what happen if I take strong acid plus weak base? Okay, for the remaining combinations, what happen? Whatever the delta H value is there, no, it will be less than 57.1 kilojoules. Generally the limited value is what 57.1. So but for remaining combination, what happened, you are getting less than 57 value. Okay, less than 57.1 indicates what, minus 62, minus 43.1. Now you will say that minus 43 is higher value, minus 57 is lower value. Okay, don't think like, don't check about the negative sign is just giving information that the energy is released. Okay, right. So move to the next one, why it is decreasing. Now the question is why. Okay, why like this happening. Okay, so let us try to understand here the reason. So actually what happened, the reason for this, why the answer is, for this combination, why it is 57.1, why for other, why it is less than 57. So let us try to understand why, what is the reason. Okay, so this reason is nothing but what, for weak acid and weak base. Okay, breakdown process is slow. Okay, breakdown process, which is nothing but dissociation, you can say. Okay, breakdown process is slow. Okay, so to what happened, so we require more energy. So we require more energy for breakdown, for breakdown. Okay, so from where it is getting this more energy. So we can write here, it require extra energy. Instead of writing more, better we can write. So we require extra energy for the breakdown. Okay. From where it is utilizing this extra energy? It is utilizing extra energy from 57 value. Okay. So this extra energy, okay, whatever the extra energy we required, okay, for the breakdown process. Okay. So now what happened for this breakdown process, whatever the extra energy we require, that energy we can call it as, we have one name. Okay. So which is nothing but what, enthalpy of ionization. Whatever the extra energy we require for the breakdown, no, that extra energy we should call it as what, enthalpy of, okay, enthalpy of ionization. What you should call that extra energy, enthalpy of ionization, or even you can call it as what, enthalpy of dissociation, enthalpy of dissociation. Clear till here? Right, so let us try to write down what is the formula for enthalpy of ionization or enthalpy of dissociation. Okay, so here what we should write, what is the formula? The formula for the enthalpy of ionization or dissociation is nothing but delta H, neutralization. Of whose neutralization we have to take, whatever that weak acid, or if you're talking weak base, whatever it is. Okay, so out of that is equal to minus 57.1 plus delta H of ionization. Okay, whatever the energy, extra energy required, that one. Okay, this formula is used when you have to use this formula, whenever in the question they are asking about what, ionization or dissociation. Clear till here? Right, so let us go for the next one. So the next one is nothing but our bond energy. Okay, how many? Fourth one, I think so, right? So the fourth one is what, bond energy. Bond energy, one more time is there, which is nothing but bond dissociation energy. Bond dissociation energy. Okay, so shortcut, how can you can write delta H B, bond dissociation energy. Okay, if you take your standard condition and standard enthalpy of bond dissociation energy. Okay, right, move to the next one here. So the next one, let us try to understand what is the required condition. Right, so coming to here required condition, how to say that the chemical reaction is eligible means, amount of heat required to break 1 mole of gaseous bond. That means a reactant. Okay, reactant must contain how many? You can take that 1 mole of gaseous. Okay, 1 mole of gaseous into separate atoms. That means product must have what? Product must have atoms. Okay, all must be in which state? Gas state. Okay, right. For example, let us take for the general example. Okay, so H2 gas gives rise to what? 2 times of H gas. Clear till here? For this it is eligible? Yes, eligible. 1 mole of reactant is there, and here both are in, and right side you have the atoms. Okay, suppose if I take here, for example, if I take here HCl. Okay, HCl gas gives rise to what, H plus gas and Cl minus gas. Okay, this is not eligible. Why? First of all, reactant is 1 mole. Yes, but the product is atoms or ions, ionic form. So we don't require ionic form. Hence, what happened? This reaction is not eligible. Okay, right. So move to the next one for polyatomic. For polyatomic, what is the meaning of polyatomic? More than two atoms. Okay, how to find out the bond dissociation energy? Let us try to understand. For example, if I take the CH4. Okay, so generally, what is the structure of CH4? C and 4 hydrogens. Okay, these are what CH4 structure. Okay, in the first step, what happened in the first step? CH4 gives rise to what, remember, we cannot break all the bonds at a time. One by one we have to break. Okay, first I'm breaking here, so what you are going to get, CH3 plus H. Now in the second step, what happened, let its delta H is equal to how much, 1. Okay, next what happened, CH3 gives rise to what, one more bond I'm breaking. Now what you will get, CH2 plus H. Okay, now what we can say here, let the delta H value will be delta H2. Next in third step, what happened, CH2 gives rise to what, CH plus H, and in the fourth step what you are going to get, CH gives rise to what, C plus H. So one by one you people have to break. Okay, this is delta H2 and this is delta H3. Okay, now I want a complete thing. So if you get complete, what happened here, you can do the later on calculation, like CH3, CH3, CH2, CH2, and these to get cancelled. So what finally you are going to get, CH4 gives rise to what, C plus 4 times of H. I want to find out what is the delta H final. Okay, now what will be the formula of delta H final? Generally what we think, if I ask you what is the bond energy of CH, okay, so generally what you will say, you people say that delta H1, okay, plus delta H2, okay, plus delta H3, okay, plus delta H4, okay, whole divided by 4. Okay, this is the first formula. This is what, bond energy of CH. But if you want to find out delta H final, so what is the final enthalpy for all the steps? So what you can write, delta H1 plus delta H2 plus delta H3 plus delta H4. Know the difference between the first formula and second formula. Clear till here? So coming to the next one for bond energy formula. Okay, so the formula for the bond energy is nothing but what, product minus reactant minus product. And so this is the second time you people are saying. First time where you have seen for combustion, what is that, reactant minus product. Second time is what, bond energy. For bond energy, what is the formula, reactant minus product. Other than this, remaining all are was product minus reactant. Only for these two examples we have what, reactant minus product. Clear till here? Right, next one is what, atomization. Okay, so the fifth one is nothing but what, enthalpy standard enthalpy of atomization. Okay, denoted by what, delta H naught A. Okay, so what is the condition for atomization? Reactant must be how much, 1 mole with a stable form. Okay, next second one is what, product must be what, gas atom. Atomic form should be there and it must be gas form. Okay, so let us take one small example here. If I take Cl2, it gives rise to what, Cl plus Cl, gas, gas. How many moles you have, 1/4. Can you see it is a stable form of gas? Yes, so this example will come under what, enthalpy of atomization. Created here. Whereas if I write like this, H2O gives rise to 2 times of H plus plus O minus 2. Okay, this is not an enthalpy of atomization. This is the enthalpy of atomization. Reason is what, these are ions. Okay, and H2O stable form is what, H2O stable form is liquid, not the gas form. Clear till here? Right, so this is a way to identify what, atomization. Right, so moving to the next one. Last one is laws of thermochemistry, last topic. Right, so next one is what, law of thermochemistry. So thermochemistry, let us try to understand here. Right, so there are total 2 laws for law of thermochemistry. One is Laplace law. Okay, let us try to understand what does the Laplace law says. Okay, for example, there is a reaction A plus B gives rise to C. Okay, let its delta H value is something plus X. Okay, Now I am going to reverse the reaction. What is that? C gives rise to A plus B. So whenever you reverse the reaction, delta H value also reverse. That means plus X will become what? Minus X. This is nothing but what? Laplace law. Okay. Coming to the next one. Second law is nothing but Hess law. Okay. What does the Hess law says? If the reaction takes place in single step or several step, the overall enthalpy will be equal to what? Each other. Okay. For example, if I write A to B, next B to C, C to D, D to A. Okay. Now the thing you have to do is, sorry. Right. So here what happened? There is cyclic reaction. Okay. First of all, you people have to answer, you have to identify which one is the starting product, which one is the final product. Okay. You can see two arrow marks towards D. That means D indicates what? Final product. Okay. Can you say there is no arrow mark at the A? It indicates what? Initial point. That means starting point. Okay, so suppose this is delta H. This will be what? This will be delta H1, this will be delta H2, and this will be delta H3. Okay, so what will be Hess law? As per Hess law, what does he says? Delta H is equal to what? Delta H1 plus delta H2 plus delta H3. These are the what? Concepts of all thermodynamics. Okay, numericals we'll do in one class. Done for the all the theory part of this